Hello, my name is Paulin Hardenberg, and I'm here with Jordan Garcia, Cole Garrett, and Jared Wells.
And in this video, we will be teaching you how to survive FEDD. But first, what the heck even is FEDD? FEDD is an acronym short for Freshman Engineering Design Day. Freshman Engineering Design Day is an opportunity for first-year engineering students to utilize the design cycle within a team of other freshmen to complete a specified project. There are many different projects that your team can do, including the hovercraft, air trajectory, concrete canoe, and many more. Our team was given the Animatronic project. Once your team knows what project you have, the best way to approach it is by using the engineering design cycle. The engineering design cycle is a series of steps that engineers follow to solve a problem or complete a task. Following this will make it simpler when designing and constructing your project for FEDD. The first step in the engineering design cycle is to ask, what's the problem? What are the constraints? For us, the problem was to design and build an animatronic figure that is capable of moving on its own in some way. Some constraints that we faced were that the animatronic figure had to fit inside a cube 0.5 meters wide and cost less than $40 to create. The second step in the engineering design cycle is to imagine, brainstorming some ideas, and then choose the best one. Possible ideas that our team came up with included constructing a robotic dinosaur, building WALL-E from the Pixar movie, or creating an animatronic hand. After some serious consideration of each possibility, our team decided that building an animatronic hand would be most practical and fitting with the constraints and limited time that we had.
The third step in the engineering design cycle is to plan. After you and your team decides what to build, it is important to make a plan for your project. This includes drawing diagrams, gathering the required materials to build your project, and planning out deadlines for certain portions of your project. Our team made multiple drawings and diagrams to help us with our design process. We also made a list of the materials we would need so that we wouldn't be running back and forth from the store every day when we realized that we were missing something important. The fourth step in the engineering design cycle is to create. Once you and your team has made a concise plan about what you're going to build and have gathered all the needed materials, it is now time to begin constructing and testing your project. When constructing your project, it is important to follow your plan so you will stay within the requirements and constraints of the design. While using the diagrams and drawings made in the planning stage, we were able to start constructing our animatronic hand almost immediately, and with great accuracy. This enabled us to save a lot of precious time during the construction phase of our project. While building the animatronic hand, we continued to test what we had made to see what was working and what had to be refined.
This leads us to the fifth step in the engineering design cycle, which is to improve. After testing your design, take note on what was and was not working so that you may be able to make changes to your design accordingly. This is probably one of the most important steps in the engineering design cycle. After all, there is no point in continuing on with a faulty design. An example of this in our own project was when we were designing the fingers to our animatronic hand. The original plastic tubing that we used was too thick and resistant, which made it difficult for the servo motor to pull. In order to fix this, we used less thick tubing and cut narrow slits to act as the joints of the finger, as seen in the following demonstration. Go ahead. Once you have completed all 5 steps in the engineering design cycle, it's time to do it all again. But don't worry. Sometimes, it is not always necessary to do all 5 steps of the engineering design cycle. Sometimes it is better and more practical to jump a few steps as long as it makes sense with what you are trying to accomplish. Use the engineering design cycle as a guide in a way that best helps you complete the task.
So, now that you have a good understanding of the engineering design cycle, what are some other things you can do to contribute to a successful FEDD experience?
So I would say some of the best things you could do to be successful at FEDD is definitely number one, make sure that you don't procrastinate, start early, start forming your plans early, brainstorming ideas, but also actually start getting the materials and getting together with the group early.
In order to be successful at FEDD, I'd say it's very important that you do not procrastinate. And then I'd also say you make sure that you guys plan around each other's schedule and you guys fit time for each other to meet. And going along with that, make sure you communicate with each other through phone numbers. So you guys need to exchange phone numbers relatively early, opposed to later. And then I'd also say the most important part is to use your resources, because NCCED has a ton of them.
Overall, I'd recommend working on a strong team dynamic.
there's very little that compares to a very efficient group, and if something goes wrong, it's nice knowing you can count on people. Other than that, I'd recommend looking at the flowchart as something other than just a piece of paper when it comes to the engineering cycle. You should actually talk with your teammates and give feedback, positive or negative, because it can only improve your product.
So during FED and the design cycle, I learned a lot of really useful traits. Like coming into it, I had no idea what a breadboard was, how to wire anything, how to code, and I learned how to use a breadboard, how to code in C somewhat relatively decently, and I also learned how servo motors work, how all the parts, moving parts inside those type of animatronic type things work.
I think the most interesting thing was how relative the concept of success was with our project, and how helpful it was to just pick an idea and just stick with it and see it through.
In the end, our project reached every milestone within the outline of our design process. As a result of our careful use of the engineering design cycle, we were able to place second within our category.